Welcome, everyone. I'm Alan Haney from ICES, and Tokunaga is my co-convener here, and this session was also remotely convened by Ketel Hamon and Mitsutaku Makino, who are not able to be here, although Ketel is online listening. And for those of you in person and virtual, if you have Q&A questions you want to add for our remote speaker, you're welcome to do that through the app. And so this session, I'm excited. Thanks for everyone for being here. And so we'll have one talk that'll be about 12 minutes. And I actually encourage you at the end of that, before you sprint out the door, to introduce yourselves to people in the room, because this really is a small world of people. And I've been to all 5 of the ECWOs, and the first one I went to, I met a bunch of my best collaborators ever. And basically I had a small session like this and talked to people, and then we went and drank cider in Gihon for the next 3 days and made great friendships and did lots of great things. So really encourage you to reach out and connect. And now, as I said, I encourage you to introduce yourself to at least one person. You could do 3, you could do 7, if you want, but introduce yourself to someone in the room and get to know some folks. And we'll be back in a little less than 30 minutes. We have 5 great talks in person coming up of fisheries around the world. So I'm really excited to see those. And then we'll have 15 minutes in the end to have a little open discussion too. So if you have general or specific questions, we'll have a chance for questions after each talk, but then some more general reflections at the end would be great. All right, thanks. So see you in a little less than 30 minutes. Thanks. Okay, thank you very much. Good to see you all again. You're old friends who now have met and know each other well. So Hing Chan will give the first talk, How Climate Change and Climate Variability Affected Trip Distance of a Commercial Fishery.
Hi, thank you for coming. I'm Ling or Michelle Chan. I'm an economist at NOAA Fisheries at the Pacific Islands Fisheries Science Center in Honolulu, Hawaii. So the main purpose of this study is to examine how climate factors affect trip distance of Hawaiian deep-set longline fisheries. So the Hawaiian deep-set longline fishery, it targets big-eye tuna and also land other tunas like yellowfin, albacore, skipjack, and other pelagic species. So the figures on the left-hand side, it shows the longline fishings. So basically, it's a vessel with miles of line with hooks submerged into water. And the hook set is set around 100 to 400 meters below sea surface. And they set the gear in the morning and then haul the fish in the afternoon or nighttime. And the figures in the middle is the fishing port, main fishing port in Honolulu with the longline vessel. So the Honolulu fishing port is in the middle of the North Pacific Ocean. So being in the centralized location in the North Pacific allows the fishing vessels the flexibility to go to different directions when the tuna species respond to climate change. And the figures on the right-hand side, it shows the spatial distribution of the Hawaiian longline vessels. These are the main Hawaiian islands. And the blue boxes are the fishing efforts. So you can see that the fishing effort has expanded quite a bit from 1991 to 2020. So the motivation of this study is there are a lot of studies which look at the climate factors affect the spatial distribution of various tuna species differently due to their unique physiological adaptation and preferred habitat. As the spatial distribution of the tuna changes in response to climate change and climate variability, the catch per unit of effort, CPUE, also will be affected. But not too many studies examine how climate factors affect the distribution of fishing effort or the trip distance. So this study is trying to link these factors together And it uses a quantitative model to estimate the impact of sea surface temperature and the ENSO events on the trip distance of Hawaiian deep-set longline fleet between 1991 to 2020. So the figures on the left-hand side, it shows that the black line, it shows the observed trip distance has been increasing over years. And the sea surface temperature of the matching hull location has been decreasing over time. That's the blue dashed line. This is because the Hawaiian longline fleet had expanded their fishing location to higher latitude and also further east into cooler waters. And the sea surface temperature of the fishing ground, which is defined as 0 to 40 degree north and 180 to 120 degree west, it shows the increasing sea surface temperature, especially after the strong La Nina event in the mid-1998. So the right-hand side graph shows that among all these 30 years period, what are the relationship of the sea surface temperature of the fishing ground and the annual effort weighted mean latitude and longitude. So it shows that the higher the sea surface temperature, the higher the latitude of the fishing location. And the lower graph, it shows that the higher sea surface temperature of the fishing ground, the annual effort weighted mean longitude is decreasing. That means the fishing effort is more to the east of Honolulu Port. And when there's an ENSO event, it changes the thermocline, the dissolved oxygen concentration, and the temperature habitat of tuna in different parts of the Pacific Oceans. And there's some study look at the how ENSO events affect the preferred habitat and the distribution of different tuna species in the North Pacific Ocean vertically, horizontally, and northward. And when I compare the trip distance with Oceanic Linear Index, ONI, the monthly trip distance is seasonal adjusted and detrended because there's a seasonal component in the trip distance for the fleet. They have shorter trips in the wintertime and the longer trips in the summertime. So we see that the left-hand side, the graph, it shows that the stronger the ENSO event, that means the ONI higher in absolute value, is the trip distance is shorter. And similarly, on the right-hand side, it shows the seasonal adjusted and detrended weighted latitude and longitude, also shows smaller variations when compared with the seasonal adjusted trend during ENSO event, especially during the stronger ENSO event. And the CPUE, catch per unit of effort, actually is an important determinant of commercial fishers' decision-making in the spatial distribution of their fishing effort. So the left-hand side graph, it shows that the deep-set trip CPUE has been decreasing over years, while the sea surface temperature of the fishing ground has been increasing. And the right-hand side graph, it shows that the 5-year running mean of the sea surface temperature of the whole fishing ground and the trip CPUE is in a negative relationships. This could be because the higher temperature, it will affect the production of phytoplankton and zooplankton on which the larvae and the juvenile tuna feeds on, and this will affect their survival. And our scientists in the Science Center also found the size of phytoplankton was a predictor of big eye tuna catch rate with a 4-year lag for the Hawaii longline fisheries. And I also look at the trip level CPUE and the relationship with ONI. So I'm looking at for those trips that happen during El Nino or La Nina events and what happened to that trip level CPUE. So it shows that for CPUE of big eye, skipjack, and non-tuna species, it was positively correlated with El Nino condition and negatively correlated with La Nina condition. but the negative correlation for the big I CPU-E and the La Nina was not significant. This could be because big I, it has a higher tolerance of low dissolved oxygen concentration compared to other tuna species, and their preferred habitat is below thermocline. So this allows them to have a wider vertical habitat. And for the yellowfin and apricot, actually the relationship is opposite. And there's also some studies support this finding that, for example, we found there are higher CPU-E of big I into the in the west side of the Hawaiian Island during El Nino because of the flattening of the thermocline in that area. Also, there's a study that found that main Hawaiian Island, north to the main Hawaiian Island, there's big I tuna hotspot developed during El Nino effect. And another study also found the yellowfin tuna habitat shift northward during La Nina effect, and it shows a stronger, higher CPU-E for the big yellowfin tuna. So the model, it has the dependent variable, trip distance or distance per fish. So this can be interpreted as like the cost per fish, and the independent variable is the monthly sea surface temperature, and the square of the ONI, so this can take care of the positive CPU-E for big I and skipjack during El Nino effect, and then positive correlation for the yellowfin and apricot during La Nina effect. And also I have the monthly diesel price, the quarterly big I by mass, the quarterly non-big I by mass, and the two policy variables, which is the WCPO, Western and Central Pacific fisheries closures, and the EPO, the Eastern Pacific fishery closures. Because the Hawaiian longline fisheries has two big I tuna catch limit for annual big I catch limit in Western and Central Pacific Ocean and the Eastern Pacific Ocean. So when the big I catch limit reach in that particular area, then the fishery will be closed for the rest of the year. And then I have the annual fixed effect, EY, and the vessel-specific effect. And I use the generalized linear model and assuming the gamma with log-link distributions as the trip distance is not normally distributed. So the model results show the expected sign, and they are significant, except for the diesel when the dependent variable is distance per fish. This could be possible if with a longer distance, but we have more catch proportionally, then the diesel price would not be a factor affecting the distance per fish. So because I'm assuming it's not linear relationship, so I have to exponentiation of the previous table coefficient to get the changes in percentage. So it shows that for a 1 degree increase in sea surface temperature, it's associated with 4.2% increase in trip distance. And for an increase of ONI from 0 to 1 is correspond to a 5% decrease in trip distance. And with stronger ONI, stronger ANSO event, it has a bigger impact on the trip distance. But the biggest effect is from the WCPO closures, because the vessel has to force to go to Eastern Pacific Ocean that's further from the Honolulu fishing port, and the opposite effect when there's a EPO closures. And with a higher big I by mass, is show a shorter distance, because with higher by mass, it's easy to find a fish, and then you will have a shorter trip distance. And increase in diesel price by dollar induce a 2% decrease in trip distance. And this paper was published in Close Climate 2 months ago, so if you want more information, you can take a look of the paper. Mahalo, and thank you.
Mahalo. We have a couple of minutes for questions. Yes. Sorry. Yeah, thanks.
Thank you very much. I just have one question about this declining trend in the CPUE. So this decline is due to changes in temperature or perhaps in fishing effort, you know?
It could be both.
Both,
yeah.
huh? And can you separate both effects?
So I'm just like showing the relationship, like what happened, was CPUE, and then what happened to the sea surface temperature of the fishing ground, yeah.
Thanks. Yeah, thanks for your talk.
Okay.
So have you thought about sort of like the predictions of this and sort of like what's coming? Like, are you moving it, or are you going to, does this tell you anything about what's likely to come in the future?
One thing that touched in the paper is there's a trend that the fishing, the landing location has becoming more in the West Coast. There, like before 2010, there's less than 5 trip or 10 trip per year that land in the West Coast. But in recent years, there are like 5% of trips that has land in the West Coast. So if my suspicion is like if with climate change or high sea surface temperature, that the fleet has go further away, then there may be more landing would be in the West Coast. So that could like affect the seafood consumption in Hawaii, especially like Hawaii have higher than the U.S. Average on the seafood consumption. Yeah, but in terms of like forecasting, it's hard to say because like ENSO events, people say, oh, it may be happen more like frequently and more intense in the future. So it's hard to say whether it will predict like correctly in the future, but at least this would be provide a baseline information of what happened to the fleet over like the 30 years period.
Thank you very much. Okay, next, thanks, Hing. Thanks. Our next speaker is Daniel van Denderen. He'll talk about socioeconomic and ecological drivers of demersal fish community catch across productive shelf regions.
Thank you. Yeah, thank you all for being here. So today I will talk about demersal fish community catch and also total fish catch, really trying to understand the drivers. And I got inspired doing this, seeing some climate change projections of demersal fish, and you can see them here. And these projections suggest, due to changes in temperature and also changes in pelagic and benthic prey, that community level biomass will decline of demersal fish, and this will also lead to a decline in potential catch by 2100. But so then, yeah, the real question is, of course, how will this affect the fisheries and how will this affect the realized catch? And to some extent, well, I think at least that by understanding how catch is varied now between systems and to what extent catch is currently driven by socioeconomic, political or environmental drivers, we can also get more realistic projections of how realized catch might vary in the future. Yeah, to get you a little bit thinking, if you see here an example for the North Sea, and we ask the question, is catch controlled by biological productivity or by some socioeconomic driver? You can then see here, I plot here a catch in tons per square kilometer, and here I plot the exploitation rate, which is a measure of how strong this community is being exploited. And this is based on a survey biomass from the North Sea. And then the figure looks like this. So in the 90s up to the 2000s, you had kind of a leveling off of the catch while your exploitation rate was high. And so this means you don't get really much more out of the system than with a relatively high or an even higher catch. But later on, you can see the catch declined quite clearly together with the exploitation rate. And so our working hypothesis is that in this declining phase, catch is much more controlled by fisheries management, and in this higher level phase, catch is controlled mainly by biological productivity. So to see this a little bit further, we then said, okay, can we see how different ecosystems and also different fisheries management regions differ in their relative importance of biological productivity versus socioeconomic and political drivers. And we compared these three regions, so that's Northwest Europe, Northeast US and Nova Scotia, and then Alaska area. And we choose these two regions because they have a high data availability. We know they differ in their fisheries management strategies, and they also have a very strong difference in cooperation. So here you have 15 countries cooperating, and here it's mainly one country that sets the fisheries management strategy. And so if catch was purely controlled by biological productivity, then you can see here catch as a function of the NPP, and this is the mean NPP over multiple years. Then you would expect that catch would increase with net primary production. And you see, well, the Northeast US and Nova Scotia have the lowest catch, and you can both see this in absolute terms, because these areas are more or less equal size, and you can see this in relative terms. But Northwest Europe has much higher catch than Alaska, even though Alaska has a higher, you could say, biological productivity, both in net prime production as well as in zooplankton production. So what is happening here? So we were thinking, well, maybe it could be that it's not only the biological productivity, but it's also the fisheries management that decide to fish these systems differently. So to examine this, we looked at the biomass-weighted F over FMSY, so that gives you an indication how strong the community is being fished. And we did this for 27 stocks in Europe, 90 stocks in Northeast US, Nova Scotia, and 21 stocks in Alaska. And just by reading the policy documents, you can already see there is a difference, because in European waters, the aim of fisheries management is to fish at or around FMSY. So this would lead to a biomass-weighted F over FMSY of around 1. And on the other side, the aim in Alaska is to fish below FMSY of 1. And so this is much more a limit than a target. So this is a difference, and this could explain part of the differences we observe in the total catch. So then looking at the real data, you can see quite clearly, well, in this period of time, the Northwest Europe was on average overfished. So most stocks had a too high exploitation rate, but more recently, F over FMSY is on average around 1. So they are on average around this target. In Northeast US, Nova Scotia, you see the same high exploitation rate in the 1980s, but they are now around 0.6. And in Alaska, you see a very different pattern. So you see the average exploitation rate on the community is always around 0.5. And this is both being driven by this objection, this idea that FMSY is not the target but a limit, and also since there is an ecosystem catch on the entire community. Okay, well, so then going back to what is biological productivity, what is socioeconomic and political drivers. So we have here now the same biomass-weighted F over FMSY, and here I put catch, the amount of catch that you get per net primary production. And for Alaska, you could see already the biomass-weighted F over FMSY didn't vary much in the previous plot. And you can see that most of the catch aggregates around a catch of 0.2 per NPP. And so all these dots are different years. For Europe and Northeast US, Nova Scotia, or Northwest Europe, you can see that, well, these systems have been much more exploited in earlier years. But actually, you see quite a clear linear relationship, especially in Northwest Europe, that a high biomass-weighted F over FMSY leads to a high catch per NPP, and a low one leads to a lower catch per NPP. And this is nice, and I will explain you why. Because if you then go back to this figure, and so again, this is total catch that you get out of these systems, and this is mean NPP. So assume that Alaska would choose a fisheries management strategy comparable to the Northwest Europe. So then we could say, okay, it is a bit of an extrapolation, but what if Alaska would be fished around an FMSY of 1? Well, then it would look like this. So Northeast US would be, well, approximately exploited as is done now. Northwest Europe would be much higher, would be the same, and Alaska would be much higher. if we follow the European management. And the same if you would follow the Alaska management in European waters, you would see something like this, so that it would be much lower. And the nice part is that this area is a management decision. So this area is socioeconomics or political drivers, and these lines is biological productivity. And this can help us, of course, to parameterize different strategies also in these more global models, just by playing around with the overall fisheries mortality we put onto these systems. So then the next question is maybe what are the trade-offs between these different fishery strategies? So what are the trade-offs between a Northwest Europe versus Alaskan strategy? And to answer that, we looked into, we used the PESTEL approach, which has been used before by Catel Hammond, who is a collaborator in this project. And she used this approach to describe future socioeconomic or socio-political scenarios for aquatic resources in Europe. And PESTEL stands for political, economic, social, technological, environmental, and legal. And basically what we try to do is to understand all the external factors that influence this fishery area. And you can see, we have these indicators, like political indicators that relate to exploitation level. What is your target of fisheries management on a single stock and maybe on the community? Economic, what is the price you get out of the systems, and also how many vessels do you have, related to labor, related to a number of commercial harvesters, fishing countries, and also, of course, to effort. To what extent do you put much more effort into a system than in the other system? Of course, I will be unable to go through all, so I will just show you the large differences, because the trade-off seems actually to be relatively simple. And so that is on one side, you have here everything to the right. That is the number of times it is higher in Northwest Europe area. And again, these areas are more or less the same size, so we can compare them in absolute terms. And everything to the left is number of times higher in Alaska waters. So there is more fishing in Northwest Europe, and that also is shown here. So there are more commercial harvesters, there are more kilowatt sea days, so there's a higher total effort on the system. There are more sea days, and the size of the fishing fleet is also 1.5 times larger than in Alaska. And we have also information on the gear types that are used within these regions. But on average, you can see that the fishing fleet size is larger. So there are more fishing operations, and you can say in a way that the social or economic sustainability is quite high in this area, and you promote a lot of jobs for a lot of people. Whether you have a high economic value is unclear, and we are not able to say that based on the data we have. But then when we look at the environmental effects of fishing, actually a lot of the patterns are in favor of Alaska. So you see a higher marine mammal biomass based on EcoPath, EcoSim simulations. You see a higher demersal biomass based on a troll survey data that we used. There's way more C4 trawling in European waters than in Alaska. So about 5 times higher area is being trawled. There's a high level of discards, both in absolute as well as in percentages. And finally, there are, at this stage, still more stocks overexploited, even though this is going quite clearly down now in European waters. So yeah, this seems to be the trade-off that, and the question is then, of course, is to what extent are these management systems transferable? So to what extent can we learn what happens in Alaska, in Northwest Europe, and vice versa? And there we have, of course, a problem, and that is population size, and that is much, much higher in Northwest Europe. So at this stage, we are actually not sure how transferable these systems are, although we do think that some of these rules can be implemented if the political and national countries are interested in or accepting either a higher environmental effect of fishing or more fishing operations. So yeah, the findings highlight the importance of just explicitly varying the exploitation rates in forward-looking scenarios. And by doing that, you can already incorporate some socioeconomic variation between regions. I think it was very interesting to see that current ecosystem management differed in the choice of fishing exploitation and just in the balance between sustainable use and conservation. And yeah, well, then these both biological productivity as well as these factors are, of course, important of driving catch. And finally, well, it seems that they have equal productive capacities. So that is the catch potential per unit of net area, of net primary production. And with that, I thank you for your attention.
If we have time for a question, if anyone have a question.
Thank you, Daniel, for the talk. Very nice. I'm not an expert of this method, and sorry for if my question is a little bit naive. Is it possible to play with bioeconomical scenarios? So with bioeconomical scenarios, so to see what would happen if we adopt this or that situation, that decision?
Yeah, so thanks for the question. Yeah, so actually we are now Catel is working with a master's student in the Netherlands and looking at this question. So which rules, at least in a theoretical scenario, can be made in the North Sea, and how will this change the fisheries? And one clear rule is, of course, to limit the amount of bottom trawling and to shift to alternative gears. But this will affect which fish you catch, with which effort you catch these fish, and which communities are able to catch these fish. So that's directly a lot of complications. But there are some of these rules, of course, can be theoretically at least explored. Yeah.
Thanks very much.
May I go for a second?
Yeah, it's a quick.
It's a quick. Exactly. So, but you showed that Europe obviously is made by a constellation of countries. What happens if we shrink the scale of the study? Is it overall possible? So instead of having this regional approach, to have a small-scale approach?
Well, the only thing is maybe that it becomes harder to set the border, and because many of the fishing fleet will move out of. But to a certain extent, you can do this also for the Baltic Sea or the North Sea separately. Yeah, within that area, you have to take a lot of the movement into account. Yeah.
Thanks again.
Thank you.
Feel free to save questions or comments also to Adam at the end. We have a section at the end to talk about. All right. Next up is Bernie. I'll let you introduce your talk. Thanks.
Thank you so much. Thanks everyone for being here. I'm Bernie Bastien, a postdoctoral fellow at the Scripps Institution of Oceanography, and my work focuses on how can we measure the impacts of climate change on the things we value from the oceans. So basically, and how to do this in a cost-benefit integrated assessment model. So to be in the same page, cost-benefit IIM consists of three main models, basically. The first one is the socioeconomic and energy model that tells us, like, given a population scenarios, and we can produce some projections on how GDP would evolve and how the energy system would produce emissions. That then enter a very simple climate model that produces temperature increase, and then the damages model that tells us how that temperature damages affects society. So the key part here, or what IIMs are used for, is to calculate the social cost of carbon mainly. The social cost of carbon, it's an experiment that tells us, like, what would happen if we emit an extra ton of CO2 to this baseline scenario. What would be the associated temperature increase, and what would be the associated changes in the damages to society? Basically, the social cost of carbon is the net present value of the area here under the curve, and basically all the damages that society experienced because of this additional extra ton of CO2. And this social cost of carbon, well, in a more formal definition, social cost of carbon in a year measures the impacts on human well-being of a ton of CO2 emitted to the atmosphere that year. So that one is used, this metric is used everywhere in policies and regulations in the US and throughout the world. Is If we were to set carbon tax, we would use the social cost of carbon, for example. Also, it informs low carbon fuel standards. It's everywhere on climate action plans, sustainability plans of all organizations, universities. It's everywhere. So it is important that we get the science right and the economics as robust as we can. However, if we look closely at the definition, it says that social cost of carbon measures impacts on human well-being. But the IAMs that we are using to calculate the social cost of carbon mostly only include, this is like a simplified box diagram of what an IAM includes. It has like the two inputs of economic production, manufactured capital and human capital, produces economic output, generates CO2 emissions, and causes climate damages on consumption of market goods and services. So basically the thing here is that most of IAMs only measure things that have a market price here. So while there are things that we value in the ocean that have market prices, I just put like as an example here, I love fish tacos, for example. There are things that are not out there in the market that we cannot buy and sell or exchange by money that still we value. There are not in these IAMs, like for example, walks by the ocean, which we call non-market ecosystem services, and just valuing the pure existence of species, for example, in the deep sea. So what I'm doing in my postdoc here is including a third form of capital, blue natural capital, or the wealth that is embedded in the oceans, to see how blue natural capital affects market goods and services, but also how it informs non-market ecosystem services and non-use values. So basically, for the rest of the talk, I'm going to talk about like these three paths. To this model, I call this model the blue dice model, which comes from the dice model, one of the first integrated assessment model of climate and the economy that earned his creator, William Nordhaus, the Nobel Prize on Economics just like a couple of years ago. And so basically, I'm going from this standard, extending the dice model to include the oceans. And basically, and that's my project that I'm doing at Scripps with some colleagues from the Center for Marine Biodiversity Conservation. And as I told you, I'm going to talk about these three parts. So starting with the first one, how I'm measuring natural capital on market goods and services. Here I'm using a very cool database from the United Nations Conference on Trade and Development. What this project did was to gather export and import value data for each country for the last 10 years on how on what is the value of exported ocean-based goods and services. So by ocean-based goods and services, what they mean is, for example, on the side of exported goods from the ocean, they have the value from processed foods, flowers and oils, living species, and ocean-based technology. And on the side of exported ocean-based services, they have the value of recreation, research, food, and accommodations in the coast. So basically, the idea is to use this information that is country level, year by year value of these services to see if we can find a climate change footprint in the fluctuations of economic growth on these benefits. So I use physical and biological responses to make an econometric regression model to see if there's a footprint on the GDP value of the ocean here. Some preliminary results is that, yes, there is a footprint. Higher sea surface temperature have a negative impacts on GDP. And these negative impacts are not equally distributed across the world. For example, countries in Middle East and Africa have like the effect or the magnitude of this effect is 10 times higher than OECD countries, for example. So on the side of non-market ecosystem services, I'm first implementing the ecosystem services that mangroves give to society, just because they are like so widely studied ecosystems, both in science and in environmental economics. So we have very well accounted what are the values that mangroves give to society, and specifically I'm looking at water capture, filtration, and purification, because this is an ecosystem services that we use, but that we don't exchange any sort of like a monetary value for it. So the problem, mangroves are declining across the world. So what I'm doing here is basically looking at how climate change, or what is the, disentangling the effect of climate change and the anthropogenic footprint on this mangrove decline. So for this, I'm using sea surface temperature, marine heat waves on the side of climate change aspects, and on the anthropogenic side, I'm doing this regression of mangrove cover on nighttime lights that are near the mangroves. No? So I'm using data from the last 20 years to see, to disentangle this relationship, no? And then be able to project what would be the effects of climate change on mangrove cover and on the values that people get from mangroves. Again, some preliminary results indicate that there's a measurable impact here. Well, not to our surprise, warmer and more disturbed places are going to be the ones that are most impacted. And also in these places, 1 degree of warming in the sea surface temperature is twice as damaging for mangrove cover than 1% of expansion on the human coastal footprint. So expanding your nighttime lights by 1%, your infrastructure here. And then finally, on the side of non-use values, I'm looking at existence values from deep sea species. So it's very easy to measure things that we can see, that we can interact with directly, but in environmental economics, the methods get harder when we want to evaluate things that are farther from us or that we don't interact with them. For example, deep sea species. We can measure ecosystems that are near the coast or near to us. To measure other ecosystems that are in the deep ocean, well, there's only like a bunch of studies, like 6 or 7 studies that have done these contingent valuation surveys in which they ask what would be their willingness to pay from a population near a deep sea ecosystem, what would be their willingness to pay to restore such ecosystem or to prevent it for further damages. But what happens when we are trying to evaluate ecosystems that are not near these populations, but ecosystems probably like in the middle of the ocean, no? And these ecosystems are, have gotten a lot of interest, as you know, like recently from deep sea mining industry, no? So the thing here is that there are no studies that measure like the majority of the ocean. So what I'm doing as part of this project, the Blue Dice project, is to do a meta-analysis bringing together primary study evaluation of these surveys and using an ecosystem model of the deep sea biomass to basically attach values to the carbon biomass in the deep ocean based on these contingent valuations and being able to estimate values across the seabed in the world for each of the countries here. So what are the preliminary results of these 3 main venues here that in which I extended the DICE model to convert it into the Blue Dice? Well, just as a context, the social cost of carbon in the Obama's administration was $43 per ton of CO2. With Trump's administration, went down to $3 per ton of CO2, and Biden put it back at $51 per ton of CO2. So we're talking about like these type of magnitudes, no? And supposedly these, all these studies should be informing these values. Very recently, the EPA and many other, the Environmental Protection Agency in the US and other global studies have gotten some new estimates of the social cost of carbon that are around like $200 per ton of CO2, which is most likely to be implemented, no, in regulatory analysis, at least in the United States. And for example, let's look at this study here, that actually this number is coming for 4 main sectors. Mainly, most of this number comes from damages to human health, but also agriculture, energy, and sea level rise. So I ran the blue dice model and estimated what would be the damages of a ton of CO2 on ocean-based economies, water quality for mangroves, and non-use values of deep sea species. So basically, the idea here is that we can get the first social cost of carbon that takes into account any values from the ocean, and we can add up these numbers. And what we should do, or the idea here, is to publish these estimates, no? that then could inform regulatory analysis and carbon policy for the future. So, for example, these 2 numbers would add up to $203, and that would be the new estimate. And thank you so much.
Thank you, Bernie. Questions?
Very cool work. Thank you for the presentation. I'm curious. There are a lot of biodiverse, ecosystem service assessments that have been conducted, and I wonder if you're looking at the climate change impacts on the biodiversity loss or ecosystem service loss. I wonder if you considered that, and also kind of thinking about how do you come up with a list of items that you need to vary? Because that's usually the difficult part when it comes to any kind of valuation work. So I'm just curious.
Yeah, no, that's right. Thanks for the question. I mean, actually, in my postdoc position at Scripps, I wasn't an ocean person or an ocean academic before this postdoc. So it's really nice to be in an institution surrounded by experts in this type of ecosystems. So the way I'm doing my list on what to include is basically who is next to my office, no? So I'm working with Lisa Levin on deep sea species, Stuart Sandin on coral reefs, Octavia Burto on mangroves. So basically it's more on that community based. And regarding ecosystem services from biodiversity, that's definitely in the list as is important. Yeah, thanks.
Thank you very much.
Thank you.
Okay, our next talk is by Dr. Dhanya Kandarattil, Livelihood Resilience in the Subtropical Coast of Kerala, India, using a structural equation modeling approach. Thanks.
Namaste to all. I'm Dhanya here to present my study on livelihood resilience in the subtropical coast of Kerala by using a structural equation model. As you all know, global economy consists of 58.3 million people, and 16% of the population depending on their protein in the fishery sector, and fish supply is also increasing. And coming to the Indian scenario, Indian fisheries sector contributed about 4% to the export, and 9.06 million ton were engaged, and it gave a livelihood to 14.5% of the people. And the fisheries sector contributing to its GDP about 1.1%, and to the agricultural GDP it's almost 5.15%. Yes. Coming to the Kerala economy, Kerala known as the God's own country, and the fisheries sector of Kerala, 25% of the fish catch of country is from Kerala, and 5% of the workforce is engaged in the fishing sector, and 1.86% of the net domestic product is also from Kerala. And please look at that is the contribution of inland and marine fisheries in India. We can see a drastic change that happened. In 1950-51, the contribution from marine is almost 71%. And when we look into 2017-18, it changed to 71% is from inland, and 29% is only from the marine sector. Then what happened to the marine sector in India? That's a question. And as a premise, I would like to say, even though Kerala boasts with the largest quality of life, the Kerala model of development is famous. That's social development. Kerala ranks social development, high social development with a low economic development. And the state's fishing community has largely been left out of from the general development experience. And this situation attracts different factors of vulnerabilities, which is much higher than that of the general population of Kerala. And this would in turn result in the uncertainty in the livelihood of fishing community in Kerala. That's why we are looking to this, and the study rests upon the following objectives, and to investigate the relative contribution of the determinants of vulnerability and livelihood diversification among the fisher folks of Kerala. And the second one, to examine the relative contribution of determinants of women empowerment and Thiramaitri among the fisher women in Kerala. Yeah, the sampling and the primary data was collected from mainly, as you all know, Kerala consists of 9 coastal districts, and we have selected 3 districts for the data collection, and we have taken both fishermen and fisher women for this study. And by looking the review of literature and all, we have constructed 6 constructs. That is governance, fishery-related factors, social factors, economic factors, poverty-related factors, and environmental factors. And as you know, the governance, the fisher population of Kerala facing lack of protection, lack of patrolling, and lack of surveillance and all. And the fishery-related factors includes fishing with light lures, pelagic fishing, they affect pelagic fishing, predator attack, reduction of fishing zone, and also opinion about the fishers are migrated to some other areas and they can't get the fish. So the social factors are there, or female child, they're considering a female child as a liability, so they want to change their reside place. Then the economic factors, they lost fishing days, increased household expenditure, indebtedness, and erratic income and low income, and lack of multiple earners in the family. And in many areas of Kerala still facing poverty-related factors also. And coming to the environmental factors, extreme weather conditions affects there, and habitat destructions also happened. Then seawall destruction. The last 2020, the Oki type of calamity, that natural calamity happened. It destructs all the houses of Kerala. And while looking to the relative contribution of the vulnerability factors, of course, they have an opinion that economic factor contributed. Economic vulnerability is very high among them, followed by fishery-related factors and environmental factors. And at this situation, the fishermen are moving to some other jobs. They are diverting their jobs to some other areas. And they are doing self-employment activities. They are acting as a tourist guide. They work as a driver, daily wage, and some other services. Then they have small-scale businesses also. And why they are diverted? Okay, then there are mainly 3 reasons: because of the risk-related factors, because the economic-related and psychological-related factors. They are shifting their jobs mainly because of the increased cost of fishing, uncertainty of income, and constant seasonal unemployment, and the income from the fishing sector is not sufficient to meet the household expenditure, and the alternative job is necessary to meet their family. And while looking to the relative contribution of livelihood diversification factors, they are diversifying their occupation because of the economic related factors, followed by the risk related factors. Then here comes the importance of government, the role of government. As you all know, back in Kerala, women are considered only for look after the family, the children, and they are doing their works. And at this time, the fishing is very low. They are facing lack of income. It is necessary to give additional income to the women. It's very important, and government of Kerala provided so many programs. One of the main program is the Thiramaitri project, which is solely it's solely for the fisher women. And while looking to the Thiramaitri project, the fisherwomen have an opinion that it gave financial stability to them. That is, they have a sustainable livelihood, accelerate the income level by alternative livelihood, and they can develop saving habits. To fishermen, they have no saving habits. They spend all their income daily. They have no saving habits to them. But while the fisherwomen came to the mainstream, they started saving. They can give good education facilities to their children, and they can they have a confidence to start enterprises. While looking to the social security, they have the confidence to start the enterprises. They have the decision-making power in their family and better standard of living. And this type of micro enterprises equips them to support their family, and they can also develop so many skills related to their enterprises. And they have an opinion that the financial stability is high, and it's followed by soft skill enhancement and the social security. And coming to the women empowerment, we have selected economic, social, political, legal, and psychological factors. The fisherwomen have an opinion that they have high level of economic independence, economic empowerment, that they have an opinion that they have increased income, economic independence is there, then rational decision making, then they can associate to some other institutions like Kudumbasri and some social self-help groups, and they can create income, and they have an opinion that economic development happened by participating such type of development programs, and followed by the social development, legal development, and the psychological development. They have improved self-esteem, self-confidence, and they have efficient in the problem solving method and better quality of life. Yes, economic empowerment ranked first, followed by social empowerment and psychological empowerment. And these are the hypotheses of model building, that Thiramaitri project has a positive effect on on enhancing the women empowerment of fishermen in Kerala. And Thiramaitri project has positive effect on reducing livelihood diversification, and women empowerment has positive effect on reducing the livelihood diversification among the fisher folks, and vulnerability has negative effect on the livelihood diversification among the fisher folks of Kerala. And this is the SEM model, and we have selected women empowerment, livelihood diversification, Thiramaitri project, and vulnerability. We can see vulnerability, high level of vulnerability leads to the livelihood diversification of fishermen. And we can reduce the vulnerability by providing government programs like Thiramaitri and such. And the Thiramaitri cannot do anything for the livelihood diversification, because livelihood diversification is mainly happened to the fishermen. And the thing is that what will happen to the traditional fishing community, while the fishermen are diverting to some other areas, and they are not ready to send their children to do this type of job. And that's a question: what happened to the traditional fishing? Such type of diversification happened. And women empowerment is also we can appreciate that is women is also a part of the income generation. And then the question is, Dhira Maitri project has no positive effects on reducing the livelihood diversification. To reduce the livelihood diversification, we want to introduce so many supporting programs to the fishermen community. And fisher folks are obviously facing high-level vulnerability due to so many factors, and this vulnerability forces them to livelihood diversification, and it provide sustainable income activities to the fishing community. And the major cause of all these vulnerabilities is actually the changing climate. That is, climate change is the main reason for the reducing the fishing days, reducing the income, and the government support to the traditional knowledge to be placed as to ensure the preservation of traditional ecological knowledge. Thank you.
Thank you very much. Time for a question?
Thank you for the presentation. I'm curious, I guess, the structural equation model. I wonder if you kind of think that if you did the same study 10 years ago or 10 years from now, do you think you're going to see some changes? In other words, some of the things like the psychological factors and political factors that you're looking at, how are these communities changing over time in a place that is probably not impacted by climate change?
Okay, thank you for your question. And of course, if we are doing the same model after 10 years, yes, there may be changes will happen because of this several programs that is introduced by the government. And back in home, government initiated so many programs to especially for the fishermen. They are giving subsidies and to buy their fishing vessels, and of course there will be change after 10 years. Thank you.
Thank you very much. Right.
Thank you, sir.
Thank you for your talk. Okay, our final talk is stakeholder engagement. And remember, stay tuned for a 50-minute discussion after this. But stakeholder engagement for the co-construction of plausible futures of French fisheries. Adrien Chevallier.
So, hi everyone. I'm very happy to talk to you today about the project we did about the co-construction of plausible futures for French fisheries. So, all you know today is that we are facing global risks for marine ecosystems, and it affects marine fisheries. So we register a decrease in all socio-political and climate scenarios in terms of the mean biomass, the total biomass. And when we look at it on a more local and more regional projection level, we see that we are a more contrasting result. So you see that in the intertropical latitudes, we observe the decrease, and towards the pole, we are more like an increase in terms of maximum catch potential. And when we look at it on a more local level, we see that the variations are even more strong, so there is a strong heterogeneity. So we need to build local future scenarios, and there is a lack of future scenarios today at local scales. So it's important to do them, and the most used approach is numerical modeling, and more seldom they are used. The stakeholder co-building workshop are used, and however, they bring lots of advantages, and these are the main advantages. So the integration of the local specificity at local levels, the interdisciplinarity and legitimacy through a plurality of visions, value, and knowledge, And also, if an outreach session is done and properly done after this work, they could be true levers for transformative change. So what we did was a participatory downscaling of socio-political and climate scenarios, and we applied our case studies to French fisheries of the North Sea and the Gulf of Lion. So the North Sea is here, the Gulf of Lion is there, and we considered a social-ecological system approach. So don't be afraid, I will do very gently, step by step. This is the design I conceived in order to do that. In blue, in turquoise blue, we have the exclusively academic activities, and in yellow, we have the participatory approaches. So let's go. So step by step, we begin with the stakeholder engagement, because it is very important to engage in long-lasting relationships with stakeholders and to understand the sustainability and the functioning of the fisheries. So after that, we build models for each social-ecological systems with these inputs from the first participatory workshop, and we jump to the step 3. It is like a parallel step because we did a digest of the global scenario literature we have in terms of sociopolitical and climate scenarios, and then we were finally ready to do a local scenario building workshop. Then all the input of the workshop was synthesized into storylines, local storylines. And now that we have model of socio-ecological system, which are semi-quantitative models, and we have also local storylines, local models, local scenarios, sorry, the idea was to implement these local scenarios into our models. So it is step 6. And then we could compare the socio-ecological system we have under each scenarios, each of the socio-political scenarios, and do a final outreach in order to trigger some transformative change. So step 1. You see that we did a first workshop series with the stakeholders. I went to their office, and there were French fish producer organizations, regional fisheries committees, and national fisheries committees, but also regional scientific teams and NGOs. It was 35 people, and we understood with them the main factors, 71 factors, following an interdisciplinary approach, which is the PESTEL approach, which begins with the political dimension, the economic dimension, the societal, technological, environmental, and legal dimensions. Then, through a reflexive thematic analysis, I could determine 71 key concepts, or 71 key variables, which are involved in the functioning and the the sustainability of the socio-ecological systems. So after this, the model approach. So this is an interaction matrix of the 71 key variables we add from the stakeholders, and it is a very simple approach, very straightforward. It is a pairwise analysis. So you have variable A, like it is here, the understandability of the administrative system and the administrative support for fishers. And the idea was to say, if this increase, so if the understandability of the administrative system and the administrative support increase, what will happen to the other variables? And for the 70 other variables. And we see that, for example, the ability to have access to the training, if there is more administrative support, will increase strongly. It is so simple. So 0.75 means strongly positive interactions. And here, the acceptability and the applicability of the regulations and the level of control will also increase, but more weakly than the access of the training, which is much more direct. So it increased with 0.25. And we also had the same interactions for the negative interactions. And with this, we have 805 interactions that we've cross-checked with several investigators. And for this, we could achieve a fuzzy cognitive mapping involving all of the dimensions. And in green, you have the positive interaction. In red, the negative interactions within the same dimension or among dimensions. So really simple at this step, but it is quite a complex social-ecological systems. And then we could jump to a digest of the global scenarios literature. And for doing this, we based our project on the storylines which were constructed by the CERES project in 2016. And we also thank the Future Mares project, which support us in order to get all this material. And we have 4 sociopolitical scenarios. So this is 4 among the 5 archetypal scenarios used by the IPCC currently. So first, the global market scenario, it is like an exacerbated globalization with an intensification of the flows, the economic flows, but all the human flow actually, all the physical flows as well. Then the national, and it is with high dependence on fossil fuels, which is really important to notice. And the national enterprise scenario is much more of a national withdrawals of all countries with, based on an economic, on a military protectionism. So it is a trend we could, all these four trends could be observed today in some countries, in all countries. So they're really pushed towards archetypal scenarios there. Then the global sustainability scenario, it is our scenario with international cooperation toward collective well-being and with high preservation of the environment. And the idea is to have a decarbonization of our economy, so reduction in fossil fuel dependence. Last but not least, our intermediary scenario in terms of emission is the scenario's local stewardship, where the governance is more decentralized and where you have a focus on local and regional issues, but also a strong heterogeneity between territories. And this is really quickly a summary quantitative analysis of the integrated modeling assessment available in the literature today. So for the key variables of each dimensions of our PESTEL approach, we did a Likert scale in order to have all the values in 2100, for the high-income countries, because we are working on French fisheries. And after this, we were ready, finally, to do our local scenario building, which is one of the main steps of the process. And the workshop design was with heterogeneous focus groups, meaning we have a wide diversity of stakeholders, which are the same stakeholders as before, but there were numerous people coming. So French fish producer organizations, regional fisheries committees, national fisheries committees, regional scientific teams, and NGOs. And we did a World Cafe, meaning that several teams will interact simultaneously in order to have a more complementary vision of our projections of future scenarios. So here is some pictures. Here are some pictures. It was quite successful because from all the inputs we gathered, we could do some local storylines. So here are two storylines, one from the Gulf of Lion, one for the North Sea, for the global sustainability scenario, where you see that the social dimensions in blue, these are the common features observed for both scenarios. In orange, these are some differences, but I have not time to read them, sorry, but you could have more time later to see the work. And then from these local storylines, we could finally implement them in our model. And how do we do that? We take only the key variables from each one of our local scenarios. So these are the most frequent variables occurring in each one of the scenarios for each one of the dimensions of our interdisciplinary approach. And we rank them by Likert scale that represents the change we will observe in the future in 2100. And so from -1 being the strong negative change, the strongest negative change, to the 1, which is the strong positive change. So you see, for example, that we have a concerted, integrated, and adaptive management, which could be all the management promoted today to have a resilience and a fisheries which is in a healthy state. And you see that we are really good state of management, really good management condition in the two first scenarios, but really negative management and big issues in terms of management for the two other scenarios. I also did another scenarios with other investigators, which is the business as usual, which is kind of intermediary, but let's focus on the four scenarios. It's quite sufficient, I guess. So after this, we put all these drivers. So we have 10 drivers because we have 5 dimensions. So for each one of the dimensions of our analysis, and we put them in the model. So they are fixed. The blue one are the fixed drivers. And we observed what happens in terms of scenarios. So here in the arrows, in the blue arrows, you can observe in dark blue, strong change, strong reduction in terms of the variable status. And in pale blue, it's like a more weakly, but still significant effect. And in orange and red, it is the positive interaction. So we observed that it was really logical. It was reassuring because we observed some changes. For example, the volume produced, The volume produced increases significantly because the ecosystem had a more healthier status in the global sustainability scenarios, but decreases strongly in all other scenarios. When we look, for example, at the social value, which is the conflict of use, you see that the conflict of use drops sharply in the global sustainability scenarios, but increases strongly in the other scenarios. And the intermediary scenario is here also intermediary. The same, for example, in environmental, you can look at, for example, the negative impact of biological invasions, and you also see decreasing trends in the first two scenarios and increasing trend in the other ones. What you can also observe is that we have less significant values in the two first scenarios. It is because of the combination of climate change and management. When you have good low climate change emissions, low climate change concentration, along with a good management, we observe less significant strong effects, positive and negative. So it is also an interesting result. And then finally, a sensitivity analysis. So we observed also that the change in our main driver, the climate change for the conference today, the ecosystem health status is very sensitive to climate change. So we have to be careful toward the implementation of the change in climate change, but we also observe that the direction is quite logical and quite linear. So there is a drop in ecosystem health status along with the climate change increase, and also the same thing, an increase in terms of social and territorial inequalities. Also, we can observe that is really reassuring that the fishing effort is not sensitive at all to climate change because it depends more on socio-economic drivers, and also that the total catch decreases consistently to what we could observe in quantitative modeling. So this was quite successful, and we were really happy to get this model and these predictions. So as a takeaway and perspective, I know it has been a lot, but I wanted to show you all we had at the moment. So transdisciplinary approaches involve key stakeholders and also make it possible to take into account the complexity underlying the functioning of the social-ecological systems. It also allows us to realize interdisciplinary local projections representing a plurality of visions, values, and knowledge. So it is very important to use these approaches for these two main reasons. And also in terms of perspectives, they can feed a quantitative model with indicators and scenarios with the values we observed. It is more the qualitative directions, but still these are really representative of an interdisciplinary framework. So they could augment quantitative model. It's what we are trying to do in the next few years. And also to raise awareness and engage decision makers, managers, and users to address the global change. So, So yes, thank you for your attention, and I think I'm done there. Thank you.
Question on to Adrien.
Yeah, thanks. Very cool work. Is there any? Did any a local scenario or narrative arise that was on the other direction of the global SSP? Like, for example, saying that okay, if the globe is going if the world is going towards a high emissions and a lot of competitiveness, probably locally we want to go counter current. Did any of that arise, or everything is more on the same direction as the global SSP?
No, in some cases, you're totally right. The stakeholders identify other pathways. For example, you know that in France, we use lots of radioactive energy. So they were thinking that in the national scenarios, with the national withdrawals, the states would focus more, for example, on this radioactive energy to fuel all these energy infrastructure. So the fisheries would be more carbon resilient, in a sense. So it is one of the French specificities, and you could have lots of specificities like that. Yeah, especially on the intermediary scenarios, which is much more heterogeneous. So based on the territories we worked with, we have different, really different scenarios in terms of the two sociological systems. So it's always interesting to have this downscaling to see the local specificities. Yeah.
Thanks again.
Thank you very much.
So I'm going to make a quick comment on, and then can I ask a question for you all, and then we'll ask others to open for questions. But so this is, as I said, this is the 5th ECWO, as you know, and so it's 2008, 2012, 2015, 2018, and now today. And it's interesting. I was a pretty lonely economist in the first ECWO. Really, not this kind of diversity. So thank you all for, the diversity of talks in the session. And then kind of in subsequent years, there was sort of more discussion. There were several different large integrated projects where there was some economics either actually presented or some discussion. And then there was more adaptation discussion in the 3rd ECWO in Brazil. And then in 2018, we had a PESL, we had a workshop actually focused on socioeconomic scenarios and developing that. And that was very productive. And then there was a lot, kind of increasing discussion about how important it is to talk about socioeconomics. And I think this meeting actually, I've been you saw this. There's been a lot of qualitative social science that vastly different than a couple of meetings ago, especially, but even the last meeting. But I think, in a sense, in the larger sense, I think there's more selling to do to sort of talk about the coupling of quantitative social science with the full process, so that we can think about both management impacts and just a broad understanding that includes human drivers and how to model those. Now, that's my comment, but I'll turn it over to you.
All right, so this is my first ECWO, so it's been a great experience for me. But my question, so I guess to you all, so I do economic research, and I'm often working with natural scientists and a social scientist. I often realize a challenge of bridging the qualitative research that emerges from social science work and then highly quantitative work that's being done by natural scientists. So I'm curious what you see as challenge in your, I guess, daily life or working life, kind of doing the coupled socioeconomic or natural coupled model. I wonder if anyone has any insights to share. I guess can open up to anyone, yeah. Or challenge or your discoveries.
So this is just a comment. I work with, I am Peruvian. I'm working in Germany, so I'm having a big project now. And I would say that the first thing is to gain trust with all the different communities in Peru. And it takes time. Huh? Usually one project of 2 years is too short to build trust. So I would say that that's the first thing. Huh?
Thanks. Yeah, I would agree with that. Or just the more time, and it takes a long time to understand modeling data, especially interdisciplinary models, and then have that kind of social trust and sense of the social system. Other responses to that? Yeah. Feel free to be liberal in how you elaborate too. You can elaborate whatever direction you like.
Thank you. So I'm a social scientist only. No physical training. And there's conferences all about marine social science. And for me, it's I really appreciate the socio-ecological systems and the models approaches, but I think there's lack of co-creation of knowledge. We talk a lot about co-creation of knowledge, but I think it's difficult for me to understand some of the just quantitative models. And I think it's difficult for quantitative people to understand us. So I think there needs to be more talks about it and just accept that knowledge can be created in different ways. And that there's social dynamics that cannot be measured, that if something changes just a bit here, like more governance or more participatory action from fish harvesters, doesn't mean that all the other aspects will change equally, because it's a social aspect and there's a power dynamics behind it, and it can change with the next government, the government people who make the policy decisions. So it's very interesting. I think when I see these models, for me, I just want to focus on one or two variables, because just in one or two variables there's a whole world. So for me, it's very difficult to oversimplify this. And I think it's me not understanding a lot, and like the other direction as well.
Thank you. That's a very helpful comment. I think, yeah. Anyone who hasn't spoken? Anyone who hasn't spoken first, and then we'll go back to the usual suspects. Yeah. Oh.
Yes, thank you very much. I think, as well as the colleague, that it is important to also make bridges when you are coming from quantitative science, because initially I had the formation in marine ecology with lots of oceanographical features, and now more and more that I'm digging into social techniques, into social science as well, and I'm especially really interested in ethnographical science. I see that it is possible to mix techniques and to make mixed approaches. So it's true that in quantitative science there's lots of oversimplification, but also it is this comes with new questions, and you can dig into it with social science. So it is really complementary to work with. So I'm really happy to see more and more scientists, young scientists, but also expert scientists who make their own pathways, and more it was the initially original profile, but now you see that it is more common. So it's a good trend to observe this, and we could be optimistic with that, I think.
Yeah, I agree. I guess that's a good moment to plug the MCs next summer, the Marine Socio-Ecological Systems. So it's in June in Yokohama, Japan, next June. And the first one of those was in 2016. It was one of the best meetings I've ever been to. It was really good at getting people to talk across disciplines, and it'll have a lot of space to do that well.
So I'm the opposite. I'm a physical scientist, and with very little social science background, except actually talking to people. And so this has been a real education. And actually, from my perspective, what happens, the things that are going on here in this room and on the talks today is actually more important than most of the stuff in all the other rooms. Because the physical science part is settled. It's done. But the part about understanding what's going to happen to the human, to society and civilization is really important. And that's what you guys are trying to do. Even though when I look at this stuff and I go, okay, but it has to be done. I got questions about how sensitive are some of the results. Are these results really sensitive to one or two numbers, or do they, by the time you add all these things together, do you just kind of get a bland porridge and there's nothing there, or is it somewhere in between? But that's my problem, not yours. So thank you.
Thank you. That's our problem too, probably. I think as people who submit papers and this kind of stuff. All right. Did you want to go?
Yeah, thanks. Speaking to that on the sensitivity analysis and all that, I agree that there are also so many assumptions in these models in climate economics, for example, or in the ones that integrate two disciplines that should be put first, and also but also I agree on the part that, we know, for example, or something that I always remind myself is we know that the value is above zero, no? For example, just in my case, studying the social cost of carbon, we know that oceans have a value to humans larger than zero in these things. Just and any number that we come up with would have a lot of there's a lot to criticize, and that's fair, because that's how we will make it better, no, and more robust. But yeah, I think that's cool to hear you saying that, no, that it's a good step starting to work with this, because we know that something we are sure is that the value is not zero, and we should start doing something. So yeah, thanks.
Thanks.
Yeah, I was reflecting on your first comment because I found it funny. The last time I was in Aqua was in 2018, and then I was surprised how much ecology there was, and I was actually somewhat liking it as an ecologist. But then, because I was thinking in the ICES meetings, where we're much more fisheries focused, there was already a clearer There were more social scientists, there were more economists. So I wonder if it's a natural thing that happens, that it's always, that so the integration always comes last. But maybe that shouldn't be the case, but I wonder if that happens usually, yeah.
Thanks. One of my 3 rules of life, don't wait to integrate, because in doing this type of work. So Cattell online had a question. She asked about so we had sort of 2 global or comparative regional studies and 6 more local. And so she was thinking about the sort of scalability of those, about how these apply across different regions, which I think that's always a question. And I think, if anyone has insights into that, I think there are different efforts to try to take some of the regional models and do those across different regions. And I think actually that's something that, because of confidential data and different reasons, we don't do that as much in fisheries as we should. And I think that in this context, that's and this kind of comes to your point, of like how much do you take these as sort of more global general results. And so I think that's something for us to, work harder to do in this context. Any comments on that, or final thoughts before happy hour, or whatever, hike up the hill, or whatever you're going to do? Definitely we welcome. So we've been asked to write a summary of our session as the conveners, and so we'll do that. But if you can use the Whova app if you have some comment, if you can send that to us by, I don't know, say 9 o'clock or tomorrow morning, 10 o'clock tomorrow morning, something like that. We'll be happy to pull it into the summary. Okay, and and in that too, if you have thoughts about we really should do this type of session, or any kind of thing like that, please feel free to share those too. So thank you all very much. Thanks especially the speakers, but thanks to everyone for being here. Appreciate it.